Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So student, in this video we are going to solve JEE 2025 question. We are solving JEE question, but the concept of this question is very important for the NEET, and I am solving the questions of JEE that is in the syllabus of the NEET. Okay, so to do very good in a NEET, we have to solve the JEE questions also. Don't skip the JEE questions. The concept is very important. Okay, so let's go through the question very well. See, a simple pendulum of length L and bob of mass m is placed on a smooth horizontal surface as shown. You can see here. Now, when electric field of strength E is switched on, here electric field is there, the bob passes the x-axis with speed v. Then value of v how much? So student, very well here, you can see very well now. The pendulum is connected here. See here, the pendulum is connected here. This is the string and here bob is there. So what will happen that here electric field is there and the pendulum is having which charge? The pendulum is having the positive charge. That means it will experience the force in which direction? In the direction of the electric field along x direction. Okay. Because of that, what will happen that? This pendulum will just like this here, because connected now. So it will just move like on a circular arc. Okay. And when the pendulum will reach here, okay, it will have some speed. Nah? So let's take initial point A and final point how much? B I have taken. Okay. Then how we will do this here, students? Here what we are going to do, remember that here see, here I have taken this dotted line here and here I have taken this. Can you see it very well? So what we have to do in this kind of question, the question can be solved by work energy theorem also, means work kinetic energy theorem, or it can be done by conservation of energy also. But here what we are going to do in a very easy way, students, we are going to apply work energy theorem. What we are going to apply? Work energy theorem. Between which point? Which point, students? Between point A and B. Work energy theorem. So according to work energy theorem, what is there? Work done from where to where? A to B is equal to change in kinetic energy. Final minus initial, that means KB minus KA. Okay. Now students, after that, work means you should understand little bit basic of the work. Work means what? Work means, if I will tell you here, see, if I talk about the work, let's take for example here, here we have one surface is there, let's take for example like this, and here one block is there. Okay. And we have applied force in this direction. Okay. And the block is sliding in this direction. So you know what is the work? Work is given here. Force, product of, remember that it is the product of force and component of force along, reverse happen. It is the product of displacement and component of force along the direction of the displacement. Okay. So force is there, we have to take this component is there. Okay. This component, this is called F parallel component. So what we can write here, the work is given here F parallel into D, or we can write here what is this? W equal to, students, F cos theta into D is it. Now this is the first situation. Similarly, what is there? Sometimes this work we can write here like here. What we have written? We have written F cos theta into D. In the same way, students, we can write here F into D cos theta also. That means here what is this? Work can be given here. It is the product of force and component of displacement along the direction of force. That means we can write here what? We can write here F into D parallel also. Maybe force is parallel to D, maybe displacement is parallel to F. Remember that here, now, because this basic is very, very important. So now what we are going to do? We are going to find out the displacement along the direction of the force. Okay, so see, F is there, and let's take for example this point I have taken M. Can you tell me this displacement MB how much? This displacement, can you tell me MB how much here? Student, if you will write here, see this MB. This MB is given by, see, force in this direction. So we are taking displacement in this direction, same direction, parallel component. So MB is how much here? It will be given here OB minus OM. OB how much? Length of the string is not going to change anyhow, is it? That means what to write here? L. Now this length L. What is OA? Same OB. OM how much in this triangle? This is L, this is 60, that means base side component, how much? L cos 60. Okay, that means cos 60 value 1 by 2, L minus L by 2, how much here? L by 2. Okay, L minus L by 2, how much here? L by 2. So now work done from A to B, force into displacement, both in same direction. So force how much here? Force is given here QE and displacement how much is there? L by 2. Now force how much is there, students? QE. No? QE. Displacement how much we have got here? L by 2. Kinetic energy at point B, kinetic energy how much? See, half mv square. Here initially no kinetic energy, 0. Okay, so what will happen at, students? Here this 2 and this 2 will cancel out. That means what we can write? V square equal to QEL by M. V square how much? QEL by M. That means V how much? When you will solve here, square root of QEL by M. That means what is the correct option? The correct option is here option B. So here you can see very well how by using the basic concept of the work and work energy theorem, how easily we have solved this question. Okay, students. So I hope so you have understood this very well. Keep studying, keep growing.